Right, here's a simple experiment we can do to find the magnetic field pattern around a bar magnet. You'll need paper, pencil, bar magnet, and at least one plotting compass. You could typically do this with Key Stage 3 students. First step, in case it gets knocked during the course of the experiment, we need to draw around the magnet so we can always put it back in the same place, so that when we draw the field pattern on the paper, it matches with where the bar magnet was. Okay, just like that, I can put it back where it should go. Okay, so you get your plotting compass, you put it on right at the end of the magnet, and the S is pointing to the north. That makes sense, north and south attract, so I'm going to put a dot on the paper at the north end of the plotting compass. Then I move the compass so that my south is now where my dot was. Okay, and then I put another dot at the north, move it again, like that, move it again. Okay, and you stop either when your trail of dots meets the edge of the paper, or when your trail of dots goes back to the magnet. Okay, and once you've got a trail of dots either to the edge of the paper or back to the magnet, that is, albeit still dot to dot, that is a complete field line. So what you then do is connect your dots up, one continuous straight line, and there's a field line. Now, I like these plotting compasses a bit better because it's a bit easier to see what's going on with the needle. So if I start from this end, you can see the north pointer is pointed to the south. Again, that makes sense. Let's do it off to one side here. So there, I put a dot at the south end. Same again. Same again. Same again. And there we've got another trail of dots. Let's see if we can do one right close. So if we're starting there, we go to there. And back to the, oops, see, knocked my magnet. So that went round like that. See if we can get one in between. Yeah, okay. And now, you can see this takes a fair bit of time. So there's a number of things you can do to keep all your students occupied during that time. If you've got enough plotting compasses, you could have, I wouldn't probably go with more than two, but you could have more than one student working, perhaps one working from this end and one working from this end, or one working on this side and one working on this side. Or potentially you could have one who's in control of the plotting compass, the other one gets the pencil, and so they take it in turns. You've got responsibility for different jobs each. Okay, and eventually you should end up with a very classic spider diagram shaped magnetic field. That is the absolute standard for a bar magnet. One thing to watch out for is other metal pieces around the room influencing your plotting compasses. In particular, one that your students maybe won't realise or think about is there's a metal bar holding the desk up here. So if you watch carefully on this plotting compass, as I just move the paper away from the metal bar, you can see it actually moves even though it's in no different location compared with the magnet. And so that's probably why my magnetic field is slightly asymmetric on the two sides, because I started with, the bar goes right underneath just there. And there you go. experiment for finding the magnetic field pattern around a bar magnet. If you get kids who are particularly fast, you could give them an extension, and you'll find some groups will go amazingly quickly and some just won't have a clue about it at all. So the extension activity here is to do it with the double magnet, and you can have different groups, some doing it south to north and some doing it south to south, and then they can see what happens to the field there as compared with there. Okay, so you can make a more complicated version by putting 2 magnets in place.